All right, hello everybody. This is Armağan from Coyotiv. I hope you're all doing fine in this pandemic, in this terrible times. Here we are on another Thursday night. Is it Thursday? I think it's Thursday. On another Thursday night, in another episode of Coyotiv Public Lecture Series. This is episode 3, and today we're going to talk about Git. Today we're going to resolve the mystery, the unknowns, the behemoth that's called Git. And I'm very excited. I'm very, very excited to be here with you today to talk about Git because it is one of the most misunderstood things in software engineering. Git is one of the most misunderstood things in software engineering. It is very simple. It is in our lives. Everybody has to deal with Git thousands times a day. And in fact, one of my friends sent me a command yesterday. You type it on your terminal and it tells you the most recent commands you used and the most frequent commands you use on your terminal. And a whopping 30% of the commands that I use on my terminal are Git related. It's Git status, Git checkout, and a tool called Git GUI. We're also going to talk about Git GUI today. I'm very excited to get started, and I want to talk about how we tackle the complexity of version control, source code management, because Git is just a tool. It is the ideals that matter. The tools, they are great. We love the tools, of course, we use them all the time. They are great, but the issue is the approach, the fundamentals, the philosophy, the thinking behind source control management and behind these version control systems. So we're going to talk a lot about this today, and I'm going to do a hands-on demonstration of what I mean when I talk about these concepts, and I hope we'll be able to at least get a basic fundamental understanding of how to manage Git workflow and stay sane. This is the title of this broadcast, of this episode, how to manage Git workflow and stay sane. This is also a topic that a lot of people have tackled in the past. There are countless and countless articles on the internet about how to manage Git. But still, we are kind of struggling with it, especially if you're a junior engineer just starting out in your career. You're like, oh, Git, well, where's 9/11? Is it 9/11? The emergency services? I don't know. In where I come from, it's 112. Where I live, it's 112. I think it's in the US, it's 9/11. So you almost always want to ask for help, and it feels like whatever you do on Git, you're breaking it. It never plays by the rules. It never does what you expect it to do. And all of these problems are, of course, relatable. All of us went through that path. But today I'm going to talk about the fundamental and the philosophy of Git and version control. And I hope this will help you in understanding, in having a better understanding of Git internals, and how Git works, why it works, and how we should be approaching it. And hopefully after today, you won't be running into a lot of trouble with Git, let's say. It's always going to be a love and hate relationship. That's a given. I even have that even now, and I've been using Git for about 10 years now. Yeah, I think I started using Git 10 years ago. So I still have those moments where like, okay, this is too much. I can't, please, where's the exit button? I didn't sign up for this. I also have some of those moments. So it's fine. Don't get discouraged. One thing you need to know is Git is there for you. It is one of the few tools that try to make your life easier versus other tools, frameworks, libraries. I'm not looking at you, React, or maybe I am, that make your life harder than they should. And Git, you wouldn't believe it, but it's like a very good friend who is always there for you, and ready to catch you whenever you fall, if you fall. So it's almost impossible to lose work with Git. This is the first thing you need to understand. You cannot break Git. I mean, of course you can, but your regular commands of checkout, merge, rebase, creating a new branch, fetch, pull, these will not break Git. If you only use these commands, there's no way that you're going to break Git. So rest assured, it's going to work out. You might do something weird and end up in a weird state, like dangling heads that are not on a branch and so on. That is normal, but Git gives you enough trouble to freak you out. I understand that, but it is kind of impossible for you to break Git, and we're also going to talk a little bit about that today. All right, how do you feel? Is everything good? Can you hear me well? Can you see me well? And let me know if there are any issues, and then we're gonna dive right into the presentation. Thank you, Steve. Yeah, that matters a lot. Tamai, no, we're not gonna look inside the Git folder today. That's a little bit advanced for our purposes today, because in fact, even though it is useful in understanding how to use Git and how Git works, it's not a must. So we're not going to look at the internals of Git today. All right. Thank you. I'm doing great. Now let me arrange a couple of things here on my second screen. Yeah, nice. All right. Great. Now, what is the problem with Git? What does Git try to do? Git tries to help you manage the history of your code, because we forget. And some smart people came up with the idea that, well, actually, you know what? We can track our changes. We can record our changes, every single line. We can give those changes names, those versions names. And at first it sounds silly. Why would you name a change? But then if you go back and look at it, look at the history, it makes total sense. And it gives you an idea of the development, of how it goes, and all the changes and the relationships of different branches of work. So in this regard, Git is mostly useful for tracking history and tracking changes. And it assumes a rather linear history in that, in the sense that no two commits can be at the same time. Almost like in real life. Humans perceive time in linear form. Time is two-dimensional for us. It might have multiple dimensions, we don't know. It's one-dimensional for us. It might have multiple dimensions, we don't know. For us, there's a past, there's a definitive right this moment, the present, and there's the future. And these never overlap. We're always in the present, we're never in the past, we're never in the future. We can never go back, we're never gonna go to the future. I hope we would be, but that's not gonna happen. So we perceive time as linear. Now I'm gonna show you a the history of a repository, and I'm going to ask what you feel about it, and I'm going to tell you what I feel about it, about the history, because if you're watching these TV shows with time travel, we're always kind of lost on the story. It's very hard to track because our minds they want to experience time in a linear fashion. It moves forward. There are points in time, yes, but it's always moving forward. So no simultaneous action, no two things can happen at the same time. For us, there's only one moment, and it is this moment, and now it's in the past. So we're always progressing. So Git fundamentally kind of works like this. You have atomic instances of changes called commits, and that's what you do when you do git commit. You create an instance in time. You say, in this moment, I'm adding this piece of code, which is amazing, which is fantastic. But then there's this idea of branches, and there's this idea of merges, and then there comes the idea of a merge conflict, and everything is like, no, I don't understand what's going on right now. Why is this? Why do I have a merge conflict, and how am I going to solve it? This is the biggest problem of managing Git, working with Git, is especially if you're in a big team, your perception of history is forced to be multidimensional. What happens is there are these branches, there are these forks all the time, and you have to keep reference to all of those forks in your mind and kind of know when they're merged, and it's very difficult to understand what's going on. And now let me switch to my screen and show you what I mean in on a repository. So all right, I hope you can see it right now. I hope you can see my screen. So what I have here is a tool called GitK, which is extremely useful, and I recommend you to look into GitK. It basically comes bundled with Git, and it is a source tree explorer or history explorer for Git. Right now we're looking at React.js source code, and you can see these blue dots are commits. So CSS tweaks, merge, branch, enhancement, display change. And this is what I'm talking about. Now, have a look at this graph. It is very easy to understand what comes after what. These things. Run prettier is after add inspectable event components plus props. It's very easy to understand. But let's scroll down a little bit and let's have a look at here. What is this here? So there was a different branch, and then something got merged. I don't know which branch I'm on anymore. And then there was another branch here, and then there's another branch. Apparently there are two commits here, this one, and this is merged here, but then it's branches again, and then there are these things. So there are two commits here, and then there's another commit here. I don't know what this branch is. Like, the colors are supposed to indicate different branches, but this is mind-boggling. This is very difficult to understand. I don't understand what's going on here. I don't know which commit is after which other commit. And I don't really know what they're changing. So it's very difficult to follow. Have a look at this graph. Is it still difficult to follow? We have a couple of commits here. We have another commit, even though it's a branch. There are no other commits around, so looks nice. And then there's this one, and then there's this. Still, there's a branch. There are a couple of commits here. and then there's a merge. This is very easy to follow. Even though there are paths that branch off, it is still kind of easy to follow, in the sense that I can almost experience linear time here. I do these, and then I go here, I come back, another commit, I go here on that branch, and I come back, and there's nothing going on here while I'm on that branch. So this looks much simpler, much easier to understand. All right. And again, we're comparing it to this, especially like with these two forks, and then they're merging, and then they're, I don't know. This is interesting. Can you understand this? What is going on here? What is this here? Oh, or here. Anytime you scroll, you run into another issue. This is not possible for a human being to understand. And thus, Git almost loses its meaning. If you cannot traverse history, and if you cannot understand history while you're traversing it, Git is kind of useless. Okay? It doesn't mean being able to commit something. How do you roll it back? How can you know, for example, what happens when you roll this commit back? Or what happens when you roll this commit back? Where do you end up? It's very difficult, very, very difficult to understand. So this is not a good way to manage Git and stay sane. I mean, you're going to go insane if you have to manage this. That's why I think, fast forward to today, and since the beginning of the year, React is keeping linear history. Now we understand what's going on. Now we understand, because now it is in a format that is natively understandable by human beings. Because again, we experience time in a linear fashion, and this is linear. There are no branches. There are no taking off in other directions. So this is actually working great. Now, tools like GitHub and GitLab are trying to give you more control over how you manage merge requests, pull requests, and they give you options to rebase them and rewrite history. And it kind of ends up on this. And you see probably each issue, each pull request is merged into, is combined into one single commit. Now, is this perfect? Look at this. Look at this GIF, this diff. This is very big. This is a huge commit. It is impossible to understand this. It is impossible. If there are any bugs in this commit, Git has a very nice tool called Bisect. What it does is it, using a binary search tree, it allows you to find the root cause of a bug. I'm not going to go into too much details. It's an advanced topic, so you can read up on it if you like. But the best part is, if you have small commits, it's very easy to find where the bug is. You can always roll back a couple of commits back and see if the bug is still happening. How are you supposed to find anything here? This is huge. This is huge. How is anybody supposed to understand and fix this if there are any issues in this commit? Because again, Git is most useful for history. Why? Because you can track the train of thought. You can track the progress of your peer. And therefore, you can almost, it's almost like writing code together next to each other, because you can see what they did almost maybe line by line. I did this, I added this commit, and then I added another commit, and I added another commit. In fact, let me tell you, Git is invented solely for this purpose, to make remote collaboration easier. It is invented, I think, in early 90s. Please correct me if I'm wrong. Maybe late 80s. I'm not even sure anymore. And in the first days, commits were shared over email. Internet is at a bare minimum. You probably don't have exposure to internet that much or that long. And right now, we do screen sharing, and we can write code and in real time and show it to our friends. We even have like live sharing, session sharing in our IDEs. But back then that wasn't the case, and they invented Git to be able to track the changes over time and to understand what you're thinking, your progress. And this is impossible. Apparently, this person, Andrew Clark, did an amazing job here with this commit, but it hasn't been that long. It's been maybe 2 weeks now since this commit. I bet they would have a hard time understanding why they did certain things here in this commit. There's no order of development, so we lose a lot of context. This is partly GitHub's fault, and it kind of forces you to have this merge all the commits in a pull request into one single commit on master branch. Therefore, it's not a very good tool for version management. I actually like GitLab better. GitLab does this perfectly. GitLab implements, has settings to implement what I'm going to show you today, the approach that I'm going to show you today. So what is really important is we shouldn't have lost the context of how Andrew Clark built their app, built this commit, built this pull request, but we did, and that is terrible. Why do we lose history? Why? There is no use to it. We don't need to lose history. The Git is very plain in plain text, and it's very simple to store, so it doesn't take a lot of space. It's performant. You don't need to lose history. But they had to. I think they had to do this because nobody wants to deal with a mess like this. What is this? There are so many parallel lines. Git K can't even show it. Like there's this blue branch here. Who knows where it's going? I think we're gonna find another blue branch somewhere here. Who knows? Who knows? So I hope I could make a good case of why Git drives you insane. And now we're gonna solve it. I'm gonna introduce a very easy way of managing Git and working in a multi-developer environment. I have a repository for that is in the background, Git SANE. It's currently empty. It has an initial commit and it has an index.js file. We're going to be building on top of this. I'm going to demonstrate working in an environment with two engineers, developer 1 and developer 2, and I'm going to demonstrate how I would build code on top of this Git SANE repository. Very simple commits just to show how collaboration should look like. And I didn't go over this before. I should have opened it maybe with this remark. I have an article from, I think, 2015, from 5 years ago, on this topic, how to manage Git workflow and stay sane. I bet some of my friends could paste the link in the chat. And In fact, let me see if I can do that right now. Yeah, I think I can. Yeah, I pasted the link in the chat. So you can always refer to this article, and it basically includes everything that I'm gonna talk about today. All right, now, great. Now what I have here is Visual Studio Code open in two different panes, and you're gonna see that this is developer 1 and this is the window of developer 2, and I'm going to demonstrate collaboration, basically how a team would work. At t equals 0 they have the same code bases, and they just pull the repository. They're just starting working. All right, it's the same same repo and in two different folders. So I just have two lines here. Const foo equals 1, const bar equals 2. I'm gonna run out of variable names because, you know, naming is the hardest thing in computer science, or one of the two, or depending on whom you ask, 3 hardest things in computer science. So developer 1 is developing functionality, adding functionality on this one. So I'm gonna say const 3 equals 3. All right, this is the contribution from developer 1. Imagine this is an entire file and method, maybe multiple files, and so on and so forth. So developer 1 wants to commit this, and then they have a second thought, and then they say, okay, let me work a little bit more on this, and I'm gonna make another commit on top. And then they do const 4 equals 4. All right, now they have two different lines, but adding 3 is fundamentally different than adding 4, and there's a progress, and they want to show this progress. And in this case, it is a little bit difficult to show this this progress. What you would normally do would be to do git add period, right? This is how pretty much everybody does it. And then it stages these changes, and then you do git commit -m, and you commit, you pick a message, and then you commit it. But then you lost the sense of progress. So this is not actually a good idea to commit everything all together. What you should do instead is to use the bundled user interface that comes with Git. On certain systems, it doesn't come bundled with Git anymore. You have to sometimes install it separately. Sometimes it's in package managers and is still bundled. But it's called Git GUI. So what you should do is you should use Git GUI, and it looks a little bit ugly on the dark mode. You should use Git GUI to commit your changes. What you do here is I unstaged the change. So you have here, they still show up as added lines. You have these 2 lines, right? And I just, even in the same file, I want to make 2 different commits. So what I do is I right click this line over here, and I say staged line for commit. All right, now it's staged. Now this change is only including one single line, and I say initialize 3. Yeah, I can't type today. And there are no periods at the end of commit messages. All right, so what I do is I commit this, and now I can also commit this. And now I click this blue icon, and it stages the entire file. It adds the entire file, and I'm fine with it because I only have 1 line in it. And then I say add 4. That's it. And then I hit command enter. It commits perfect. Now I have add 4 and initialize 3 in my commits. Now I do a git push, right? And here, you have, if you refresh, you see we have a couple of commits. So far, so good. Nothing magical. It works, but this is not a good idea. You should never commit to the main branch or the master branch. So what you should do instead is you should be checking out your own branch or feature branch. Let's say I want to add 6. What I should do as a developer would be to check out -b. And there are various conventions for this. I prefer, if you are using an issue tracker, I prefer using the issue ID as the branch name. And I'm ambivalent about semantic branch names and so on, like that start with feature / or bug fix /. I'm a little bit ambivalent about that. So I'm just gonna say add 6 as a branch. Now I'm on a different branch, and here I should be adding 6 equals 6. All right, great, perfect. And then I should be committing it. I do git qui. This gives me a chance to do code reviews. I see, okay, this is fine. This is exactly what I want. I stage this. I say add 6. I commit. And then I do git push. And it's, of course, Git is our friend. It gives us this friendly warning that I need to set upstream. I do git push, and it says, okay, create a pull request for add 6 on GitHub by visiting this. So let's visit that link and see what happens. All right, add 6, we're able to merge. We create a pull request. That's great. Now, GitHub has a very, unfortunately, secret, almost secret URL right now. What you do is you can actually go to your repo / network graph and see what your network graph looks like. So this was the main branch, and this is the add 6 branch. All right, there is a comment on this and says, thank you for this wonderful pull request. Could you also add 7? I added as a single comment, and then, yeah, we get this. Okay, we say, sure. And I'm not going to do that because you're going to think that I'm talking to myself. I'm the developer here. I'm going to add 7. This is great. Now I also added 7. Let me do git qui. I do add 7. All right. And I do git push. Now, if we come back in this screen, we're going to see there are 2 different commits right now. At 6 and at 7. And I basically don't have any consistency in commit messages today. Please don't do this. All right, so I resolved the conversation. I also added 7. That's perfect. Now I'm ready to merge. But Steve is right in the chat. Where is 5? Terrible. Where is 5? There's no 5. So we pull the brakes and say, wait, we cannot merge this. We first have to merge 5. We first have to add 5. And 5 is a different method. It's a different module, and this developer cannot do that. So we call on the help of the second developer. and then they are adding 5. Const 5 equals 5. We ask them to add 5, they do that. And of course, they check out a new branch, add 5. They do add their changes. They do git commit -m, add 5. And they do git push. They also need to do this. Perfect. And then another link to follow to create yet another pull request. Amazing. Oh, wow. Wait, can't automatically merge. Don't worry, you can still create the pull request. All right, let's create the pull request. Why can't we automatically merge? This branch has conflicts that must be resolved. Use the web editor or the command line to resolve conflicts. All right. So what do you usually do in this scenario? As a developer, you have the merge conflict. You ask the second developer to do a git pull, right? You tell them, hey, your code is not updated. So could you please update your code because there's a merge conflict right now. Why is there a conflict? Because the repository has 3 and 4, but this developer does not have 3 and 4. Let's actually also go to the network and see how the network is looking right now. So see here, we had these commits, and then this was the master branch, the main branch, and then you have add 4 here. We had up to 4, and then this person wanted to add 6 and add 7, and then this person wanted to add 5. But see where their base commit is. They are based on top of add index.js. Why? This doesn't make sense at all. And then we tell them to merge, to get the recent changes on the main branch, right? So what they do is they do a git pull. All right, what happens? This is a new feature in Git that I'm so happy to have. It gives you a warning. It says pulling without specifying how to reconcile divergent branches is discouraged. Just don't do this. You can squelch this message by running one of the following commands sometime before your next pull. Git config pull rebase false, git config pull rebase true, and git config pull ff only. This didn't exist before, and the default strategy was merge. And right now, I think, yeah, right now it's gonna merge the changes when I do git pull origin master, because you tell them, hey, main, the main branch in the origin changed, so can you do git pull origin main? And then there is, of course, the conflict that we had. So what do we see here? We need to resolve this, right? We're like, okay, so apparently they added 3 and 4. Then none of these changes are true on their own. I have to take this out, put it here, delete these lines. For the panes, I could, but there's nothing in the panes. I can make the editor bigger though, if it is an issue. Steve, please let me know. So I do this and then commit the results. All right, what do I do? Merge conflict in index.js, automatic merge failed, fix conflicts, and then commit the results. Git status. Oh, I'm very, okay, both modified. I think I need to do add, right? And then I do no changes added to commit. And then what do? I do git status, changes to be committed. I commit fix merge conflict. A terrible name. And then let's have a look at git log. Fix merge conflict, add 5, add 4, initialize 3, and something. And then I do, I think I can now do a git push, right? Okay, I'm happy I was able to push. Let's go and check our branch. What is going on here? I had this add 5, and then this, and then I have a fix merge conflict. Can I merge it right now? Okay, I can merge it right now. Let's merge it. Add 5. Perfect. I refresh the network. All right, I was able to merge. And then we have add 6. Now, can I merge add 6 now? Oh no, I cannot automatically merge it. So I say, hey, developer 1, you have a conflict, a merge conflict right now. So go back and solve it. So what they do is, okay, git pull origin main. And now, yes, I have this. And then I say, okay, then I added 6 and 7. So they should come after 5. And I remove these lines over here. And I have this perfect file. And okay, what do? I do git status. It tells me, okay, I need to add these things. I do git add. And then I do git commit -m fix merge conflict. Okay, I'm back to green again. Now I can push. Perfect, right? Let's have a look at the network graph. All right, it's getting a little bit messy over here, but I can merge it. So I'm gonna merge it. Perfect. I'm able to merge. Let's have a look at our history. Amazing, isn't it beautiful? No, it's not beautiful. It's terrible. In just a couple of lines, I was able to create terror. Nobody understands what's going on here. We didn't need this complexity at all. This is a terrible idea. What's going on here? I have these, so these index.js initialize 3 and 4. And then I have add 6, add 7. And then somewhere here we have add 5. And then we have merge conflict. And what are these actually? Like, there is logic apparently here in these commits. So you go and see I'm fixing merge conflict, but I fix it by implementing a functionality. Why is my functionality implementation under the name fix merge conflict? If this fix merge conflict adding 5, where is my original add 5 commit? Add 7, add 6. Okay, it's here. Interesting. Add 5. All right. This is interesting. This claims that it is foo bar 5. And then this claims it is foo bar 3, 4, 5, 6, 7. Which one is correct? Which one is true? It's impossible to know. Now, this is a terrible approach. But this is what most teams do, right? This is why Git is warning you. And it says, pulling without specifying how to reconcile divergent branches is discouraged. It's it's not it's not trying to freak you out. It's trying to help you. This is a very, very helpful message. And in fact, I am always using git config purebase true. You're also going to see it in the article. So I'm very happy to see this message. I have never seen this message before. I don't know when it became the when it got implemented to warn the users, but the default strategy, merging, is unfortunately a historical artifact that doesn't work for our teams in 2020 anymore. In fact, we should be able to linearly experience this network graph. These are very simple commits. Who cares in what order they are, you might say, but these are reflecting real development teams and their real work. So these should be linear, and it should be on the order of implementation. So we're gonna do, we're gonna roll back a little bit. We're gonna undo, let's say. I don't want this mess at all. This is a terrible, terrible idea. So what I'm going to do is I'm going to roll back the changes. Now I'm on add 6 branch, right? Let's go to first, let's have our, let's remove the merge conflict. We had up to 4, and then we wanted to add 6 and 7, right? So let's force push the branch. Now, one thing people will tell you about Git is force push is a terrible idea, and I reject that. It's actually a very good idea, and I'm going to tell you why. They also tell you that rewriting history is a bad idea. But if you don't rewrite history, this is what you end up with. And this is much worse than rewriting history. Who wouldn't like to rewrite their pieces of history, their country's history, to be more successful, or to avoid certain selection of certain choices? So rewriting history is actually a great idea, something we wanted to do since the beginning of time, or history itself. So let's clear these. Also here, I'm doing git reset hard head -1. That is basically rolling back the last commit. And then I'm gonna do git checkout main here. We had initialize 3 and add 4. I'm basically rolling back all the changes, and I'm force pushing the main branch as well. And now let's keep this network open, because that's going to be okay. We keep the network open, and we have this original version. Let's say this is how we were, right? We had these developers who are trying to add 6 and 7, and then the second developer wanted to add 5. All right. Whew, this looks better than this. So let's fix this. And this is how you should be working with Git the entire time. First, let's go up and listen to good advice and copy this git config purebase true. And it says you can replace git config with git config global to set the default. Perfect. So what I'm going to do is I'm going to do git config global purebase true. By doing this, I'm enabling --rebase by default. So now, from now on, whenever you do git pull, it will always do a rebase action. What does rebase mean? Now, this developer who is trying to add 5, their base commit is in the past. It's not current, up to date with the main branch, and they are trying to integrate with the main branch. So this is not okay. If we go to their pull request right now. Okay, let's also open a pull request. Add 5. And yeah, thank you. We know that we can't automatically merge. And let's open another pull request. Add 6. All right, we now have 2 pull requests, add 5 and add 6. And we can't merge any of them. Here, okay, we can close these tabs. We have add 6. This also doesn't work. Let's open add 5 here. Add 5 and add 6. Okay, we can merge 6, but we don't want to. We want to wait. We want to merge add 5 first, because that is what has to come first. I'm not going to refresh this. I hope I won't refresh it accidentally. So this is our network graph right now. As I was saying, the base commit of 5 is in the past. Nobody wants this. Imagine you are the repository maintainer. Your responsibility is to maintain the main branch and the integrity of the main branch. And what you want to do, the only thing you want to do is to have this add 5 commit in the main branch, right? From your point of view, from the perspective of the main branch, this doesn't matter. The where 5 is coming from doesn't matter. It doesn't matter which base it is using. Add 5 is currently using add index.js as a base commit. Main branch doesn't care. Because from the perspective of the main branch, add 5 doesn't exist yet. Now, why is this based on the index.js? Because the developer of the add 5 branch, the second developer just forgot to do a proper pull, do a proper rebase before they wrote code. That is the only reason. They had a copy of this repository in the past, and then they just added on top without updating their repository. But why do we care as the main branch? We don't. What should happen? What should the main branch, what the main branch should tell to add 5 branch is update yourself. I don't care. You don't exist. I don't care that you are working on this for 3 days, for example. From my point of view, you are not existing yet. So this graph is actually the same in functionality if add 5 used the latest commit on the main branch. And this is basically the philosophy that I want to talk about today. You have to always rebase your branches on top of the main branch, always. Whenever you are pushing code, whenever you are opening a pull request. Right now, we cannot merge 5 because it's conflicting. Whose responsibility is it to solve this conflict? It is the developer of the add 5 branch. Main doesn't care. The add 5 branch should, hi Ilkay, the add 5 branch should fix this merge conflict. Again, we don't care if the developer of the add 5 branch wrote this entire pull request of a single line in 2 weeks or 3 weeks. From our point of view as the main branch, it has to come after what is in the main branch, because history should be linear, time should be linear, and this is not linear right now. Add 5 has its roots in this commit. This is why we're not able to merge, because add 5 thinks that there's only foo and bar in the repository, but in fact the main branch has moved on. And in the main branch, you have up to 4. There's 3 and there's also 4 that are not existing in the add 5 branch. So in fact, add 5 branch is wrong, is factually wrong. They have a wrong understanding of time. On their heads, time has been experienced differently. They have foo and bar. They don't have 3, they don't have 4. But that's factually wrong because they are in our repository. So what should happen in this case is 5 should be rebased on top of main. And you usually do this by saying git pull -- rebase origin master. Main. You could do that. But since now we have configured our Git globally to use rebase all the time, we can safely do git pull origin main. And again, we're going to have this merge conflict. Why? Because we're trying to add 5. And then we see, okay, in the main branch, there is 3 and 4. So what this should look like is this, 3 and 4. And then, oh, what do? I do git status. It says, okay, there is fix conflicts and then git rebase continue. But I fixed the conflict. What do you want? What's wrong? And the way to solve it is git add the file and then do git rebase continue. And you are right now, it also asks you to add a commit message, or you could just commit and then also do git rebase continue. And now we have a linear history in our branch. Add 5 comes after add 4 and initialize 3. We rebased it. Now let me push this. Oh wait, it doesn't allow me to push. Updates were rejected because the tip of your current branch is behind its remote counterpart. Integrate the remote changes. For example, git pull before pushing again. Now Git is trying to be helpful, but here it is actually tricking you. You don't do git pull here. What you do is you need to force push. Now, this was the picture in the remote repository, right? We have add index.js, initialize 3, and add 4. What we did is a rebase operation. So now add 5 comes after add 4. So Git doesn't know how to understand this push operation. We have to push it forcefully and say, this is the correct version. The version that I have right now is the correct version. Now I'm going to keep this tab as well and show you how it looks right now. See, I rebased add 5. It was like this. I moved the base commit from add index.js to add 5. And I force pushed it. Therefore, add 5 can be automatically merged. And I merge this. Great. Now, how does our history look? Perfect. It's linear. Initialize 3, add 4, add 5. And now add 6 is a problem. Add 6 and add 7. Now I can, now if you go back to add 6, the pull request, you are unable to automatically merge it because we still have the merge conflict right now on this branch. So what are we supposed to do here? We need to resolve this merge conflict. Oh, by the way, please notice that there are no fixed merge conflict commits anymore on add 5. The developer of add 5 did a rebase and now the main branch is happy. Now it's time for the developer of this branch to do the same. Again, from the point of view of main, this branch doesn't exist. It's not merged. So it can move. Its base can change. Yeah, sure. This developer 1 checked it out on this commit, add 4. Sure. and added 6 and 7, but the reality has moved on. So the developer of this branch should update their understanding of the reality. They now have a wrong picture. They think after 4 comes 6, but in fact, after 4 comes 5. So what they should do in this case is also another rebase. Let's do that. Here we are. We're on the main branch. Let's check out add 6. See, we have 6 and 7, but we think before them there's 4. Now we will do git pull origin main. All right, another conflict. Okay, I have to solve this. Accept both changes. I think accepting both changes is the way to go. And yeah, now 5 and 6 are supposed to be here in this order, and this is great. You have to notice something. The conflict came up when I'm trying to add 6 and not after I have also added 7. So the conflict came up very locally in the commit that actually caused that conflict. This is why you should have atomic commits, really small commits, so that if there's going to happen a merge conflict, you can identify them immediately and resolve them. So perfect. What do we do now? We have both modified this. We do git add, we do git commit. What am I going to type here? I don't know. This, what was my commit message before? Can I do git log? No, that's not very helpful. What if I do git GUI? All right. I'm sorry, I don't know how to make git GUI bigger. I think I will. Oh, sorry. I think I'm gonna figure that out later, maybe for the next episode. Okay, but nice. There's a commit message here already at 6. Yes, this was my commit message. So git GUI actually helped me. And I do a code review. This is exactly what I want. I commit it. Perfect. Now I do git rebase continue. And I was able to successfully rebase. There were no merge conflicts on the other commit, on the commit that introduced 7. If you do git log here, you're going to see add 7 is there as well. So I was able to understand where the commit happened. The commit happened between 6 and 5. 7 had nothing to do with this. So I was able to immediately apply the commit for 7, adding 7. I hope this kind of illustrates you the issues that you would run into in real life. Imagine the huge pull request that was merged as one single commit. You would lose this context. Why do I lose the context of 6 and 7 as different commits? What if there is a merge conflict? How do I solve it? How do I know where to solve it? How do I know which commit is the issue? Is 7 the issue or is 6 the issue? It turns out in this case 6 was the issue, and I was able to immediately solve it. Now I force push this to the remote, and now let's keep this. Hello, Sarah. It's a great tool, and we talked about this earlier in the stream. I just like to use it. It's a wonderful tool. It is much easier than the command line because it's visual and it gives you a chance to do a code review before you commit something, which is really important. And it also lets you commit your changes line by line. That's also very important. So now this was how it looked before, and now we had merged 5, and this was how it looked before with branch 6, and now we rebased that as well, and it's looking very sweet. And this is actually factually also correct. We had initialize 3, add 4, we have add 5, add 6, and add 7. Amazing. Amazing. Great. Now, Now I'm ready to merge this. Add 5 and add 6. And we are able to automatically merge it. Now, usually there is also this rebase and merge. These two commits from this branch will be rebased and added to the base branch. And you think rebasing here is doing the same thing. So you say, okay, sure, confirm rebase and merge. In certain cases, you don't always have merge conflicts, but still the commits are from the past. So you say, okay, rebase and merge. And then, what happened here? Add 6 and add 7. They are on the master branch. But now I lost context. Here I knew that add 5 was an effort on its own, and I merged it. I actually wanted the same for this branch. Add 6 and 7. When they're on master branch, you don't know how they're related. You don't know if these two different commits came as a result of the same work package. You also lose all the context of the pull request and everything. So I actually don't recommend doing this approach. That rebase and merge button on GitHub never works for me because it leads to this. And now I lost, is 6 related to 7? Could 6 exist on its own without the 7? Does it make sense? I cannot trace back to my issue tracker and so on and so forth. This is really weird for me. So I'm going to roll these back. I will do git checkout main, and I will do git pull and git log. You see add 7 and 6 are 2 separate commits. This time I'm going to roll back by 2 commits. It reset hard head -2 and git push -f. So I update remote, and when you refresh, you're going to see that we're back before we merged this pull request. So let's open this pull request again. Yeah, let's open this pull request again. We do new pull request. We have add 6. Looks great. Create pull requests. Create pull requests. Nice. I want to add 6 and 7. Looks great. Now, what if I choose squash and merge? The 2 commits from this branch will be combined into 1 commit in the base branch. Now, if you do this, you're going to see we run into the issue with the React repository. Let's do it. Squash and merge. Okay, let's see how the network graph looks right now. Now they are combined, and it took the name of the pull request, add 6, but now there's 1 single commit in the main branch, and 6 and 7. These 2 lines were different. They belong to different commits. Why do I have this issue right now? It is the same issue with this. There's no way that this is 1 single commit when it was being developed. But what they did was they did squash and merge, and in the repo we now have this as 1 single commit. But we lose so much context. Why do I lose the context of 6 being different than 7? That was progress, right? That showed the progress of the developer, of the first developer 1. This also doesn't make sense. So I also don't prefer doing it this way. So I'm gonna roll back once more. This was on the correct commit, so I force push again. Now if you refresh, you're gonna see we're back to almost square one. I'm going to create another pull request. This time we're gonna do it folks. I know we're a little bit late, but bear with me. This is very exciting, and I hope to give you the gist of the idea here. Add 6, create pull request, and now I'm not gonna do squash and merge. I'm just gonna do create a merge commit. Add 6, and let's see how it looks right now. We merged it. Let's see how it looks here. Perfect. This is what I'm talking about. This is linear history. This is keeping the context of the changes. It tells me that there were 4 commits on the main branch, and then we added 5 as part of a collaboration. And then we went back to the drawing board, more collaboration. We added 6 and 7 as part of another batch of work. This was on a different branch, but it almost like this happened in an instant for the main branch. Therefore, there are no other commits here. And then we merge it, and we're easily able to track the history linearly. 5, 6, 7, and bam, we are on the main branch. All right, I hope I was able to illustrate how you should work with Git. Always do a rebase. Always have this linear history. GitHub doesn't allow you to automatically do this. GitLab enforces this automatically. They don't lose the merge commits. GitHub, I think, doesn't really understand that those are important. So they cannot do it automatically. So you have to manually make sure the network tab is clean, the network graph is clean, and it's linear. Amazing. So, all right. I think I have everything I need here that I wanted to show you today. We have 5, 6, and 7 as individual commits. We have that context. Historical context is always important. Being able to atomically identify the changes in history is really, really important. In the future, you can see that these 2 came together, but 5 needed to exist before, and the order is restored. The order is guaranteed. All right. There are a couple of other things that I wanted to talk about later. I think we're going to do another session on Git, this time focusing on collaboration of different environments, not different developers, but different environments, because obviously you want to push your code to production. There might be a testing environment, there might be a staging environment. So how should you work with those? That discussion, though, is not as important as this one. Once you get this up and running, once you have this embedded in your team as a practice, the rest, you can do whatever you want. You can have individual branches, you can have tags for production builds, for test builds. But what is really important is that you keep a clean history. Steve asks if there are any downsides to rebase versus plain merge. I haven't come across any. The issue is it might be difficult if you don't do this often. You have to rebase constantly. Every day rebase your work onto the target branch. Every day, or maybe multiple times a day. Because once you are, behind by a couple of days, it becomes infinitely more difficult to resolve all those merge conflicts. So you have to do this as frequently as possible to be successful. And another downside is with force pushes on shared branches. Your colleagues will have a different perspective on history. They will have a different understanding of reality. Their realities will be different than yours if you're rebasing. That's why Git rejects your pushes. That's why you have to do force push. And is kind of difficult to work in a team setting where constant rebase is not a practice that everybody does all the time. So get your teams used to constantly rebasing their code bases, and you're going to see much less merge conflicts, and you see there are no I've fixed this conflict commits, which is much better than having those weird fixed merge conflict commits. This was what naturally would happen if we didn't do any rebases, and this is how it is right now. We unentangled, is that a word? Unentangled the mess here. What is this? And there are 2 fixed merge conflict commits here. Who cares? Why? After 4 comes 6 and 7 and then 5. This is correct from the point of view of an outside observer. This was the timeline of how it happened. We had 4 and then we added 6 and 7, and then we figured out that we did something wrong and we had to add 5. But from the point of view of master, this doesn't make any sense. We don't care. What we want is very simply 2, 3, 4, 5, 6, and 7. From the point of view of master, this should have been the truth, and we made it happen. So this is pretty much everything that I'm going to tell you today. But before we wrap up, there is one more thing. I wanted to do this before Apple does it next week. I'm looking forward to the new Macs. So I told you there's a command in Git that is a lifesaver. So you can never really break it, and that is reflog. You do Git Reflog, and here you see all the action that happened. Here you see all the action that happened in your repository. You see rebases, you see pulling the master, moving from main to add 6, moving from add 6 to main. You see your rollbacks, everything. So every action is recorded in the mind of Git. So, for example, let's check out add 6 to main. Let's check out this, for example. Git checkout, and then we are at a different commit in the history of this local Git repository. You do Git Reflog, and you see that is also recorded here. Every action you take is recorded in Git's local memory. What is really important is you shouldn't lose access to your computer. You shouldn't lose this directory. Unless you lose this directory, all the actions you do are recorded in a way that you can always undo. You can always undo resets. You can always undo merges. You can always undo rebases. So never fear. You will never lose work unless you lose this folder. If the files are deleted, of course, nobody will remember. And I think, as far as I know, you cannot also push reflog to a remote repository. So you shouldn't really lose your computer. Reflog is a local tool. So let's do git checkout main, and yeah, we have at 6, at 7, 5, 4, 3, 2, 1, cut. I would love to end like this. It would be perfect if I could do this, but unfortunately our production is not that advanced yet. But anyway, all right. I hope you enjoyed today's lecture on Git. Again, I couldn't manage time. I know we are over time by like 10, 15 minutes. Yes, but I think we did a great job at demonstrating what you should do with Git and how you should be using Git. As a result, as a TLDR of this entire lecture, always rebase. Always rebase your code, always rebase your branch onto the main branch. Never work on the main branch, always work on a feature branch, and always make sure that it's at the end, at the edge of the main branch when you are opening a pull request. All right. Thank you. Next week, we're going to be together for another lecture. I'm not sure what we have in the program, but stay tuned. Stay locked onto the channel, subscribe to the channel, hit that bell icon so that you're going to get notified when we release the next video for next week. And we're going to keep doing these public lectures as long as you keep enjoying them. So also let us know about your experiences. Oh, also Paloma is here. If you also liked the Twitter clone broadcasts that we did with Paloma, give a thumbs up, and maybe we can convince her to do the next episode with us on this on the Twitter broadcast, because I love that. That was a great project. I want to keep doing that. All right, folks, have a good night. This was amazing to be with you. I'm looking forward to doing this together with you next week. On this day, in this hour, I'm gonna see you again. In the meantime, remember to always rebase, remember to have linear history, and also remember to have fun. Don't forget, coding is about having fun. Have a good night.